Here's a brief rundown of these notes for Friday. So we have talked about reducing radicals and stuff before in last chapter. This chapter, it's just square roots, and so specifically it's the square root of negative numbers. Since you can't take the square root of negative numbers, the imaginary unit, I, was created. So normally, and you can look at the filled out notes for this, you would have the square root of 50, and we talked about these rules for radicals that we can split that up into the square root of 25 times the square root of 2. That's going to become 5 times the square root of 2. But what happens if we take the square root of negative 50? That's where this imaginary number comes from. So the imaginary number is I, which is the square root of negative 1. So now we could split that up into the square root of 50 times the square root of negative 1. We can simplify the square root of 50. We know that I equals the square root of negative 1. So that's going to replace your square root of the negative there. So we can take out that negative. The square root of 50 reduces to 5 radical 2, like we just did. But then now we would say the square root of negative 50 is 5i times the square root of 2. If you had the square root of negative 9, that would be the square root of 9 times the square root of negative 1. So then that would become 3i. The other thing you can do is if you take I squared, so let's do I squared, that would equal the square root of negative 1 squared, which is just going to equal negative 1. So now we can say that I squared equals negative 1. And so anytime you have I squared in a problem, you can replace that with negative 1. You can use that then for any exponent or any power of I. So if we had I cubed, that would be I squared times I. I squared is negative 1, so that'd be negative 1 times the square root of negative 1. So that just becomes negative square root of negative 1. So I to the third is negative square root of negative 1. I to the fourth would be I squared times I squared, which is negative 1 times negative 1. So that just becomes positive 1. So if we look here, it starts, I squared is negative 1. I cubed is negative I, or negative radical negative 1. I to the fourth would be positive 1. If we did I to the fifth, that would become I squared times I squared times I. So then that's just negative 1 times negative 1 times the square root of negative 1. So then that just goes back to positive square root of negative 1, or just I. Then you would have I to the sixth, so that would be I squared times I squared times I squared, which is negative 1 times negative 1 times negative 1. So then that just goes back to negative 1. So you can just do that for any exponent of I. It's just going to keep following that pattern. So it'd be negative 1, negative I, or negative square root of 1, 1, square root of negative 1, back to I, then back to I squared. So you can use that pattern to figure out any power. So then we can use that to break these down. So that would become 294, square root of 294, times the square root of negative 1. And I'll have you look at the filled out note sheets, but that will break down. We can simplify 294, and then the negative square root, or square root of negative 1, just becomes I. Same thing here. This would become 75 times the square root of negative 1. So that square root of negative 1 becomes I, and we reduce the radical the same. here we can remember that I squared equals -1. So we could rewrite this as I times the square root of 10. We can take out that negative, times I square root of 15. Now we can use our properties of radicals. We can multiply the i's together. That becomes I squared times the square root of 150. And then I squared becomes -1. So we'd have -1 times the square root of 150, and then we can reduce from there. So you would end up with a reduced radical with a negative on the outside. Numbers that have imaginary numbers in them are part of the complex number group. So that's anything with a real number and an imaginary number. So now we can add and subtract and multiply and divide these numbers with I. Again, I'll let you look at the filled out note sheets, but we want to combine these real terms, so the 8 and the 4. That becomes 8 minus 4, and then we can combine the imaginary parts, so that would be plus 3i minus -10 becomes positive 10i. So then that would give us 4 plus 13i. For multiplication, oops, your sheet should have this, but that should be multiply there. I didn't update this in my computer. But we're going to multiply, and we're going to FOIL. So multiply the first ones, multiply the outer ones, multiply the inner ones, and then multiply the last ones. So that's going to give you your new term. You're going to get I squared in there. So that gives us 8 minus 4i plus 12i minus 6i squared. So then we can remember that I squared equals -1. So we're going to replace that I squared with -1. So we end up with 8, and then that's -6 times -1 becomes plus 6 minus 4i plus 12i. We can reduce that down to there. Here's another one. In your note sheet, it should say 7 minus 5j. So the j in here is going to work like your imaginary unit. So we're just multiplying 3 plus 2j times 7 minus 5j. So here, j squared is going to be like your I squared, where that equals -1. So we can multiply those together and put that into volts. And then the final thing, solving, we're going to solve it just like normal. And again, refer back to the filled out note sheets to see all this. But we can solve this like we normally would. X squared equals -81. Take the square root of both sides. And remember, when you take the square root of both sides, we get plus or minus. We've got a negative underneath this radical now. Normally you would say no real solutions, but now that we know about the imaginary number, we can say that x equals positive or negative 9i. And then here we would subtract 27. 3x squared equals -27. Divide by 3. X squared equals -9. Same thing, square root both sides is going to give us a plus or a minus. And then the square root of -9 is 3i.